You've clicked Sign In with Google 100 times, but have you ever stopped to think about what's actually happening? You click the button, you get bounced to Google, you log in there. Google asks, "Do you want to let this app access your info?" You say yes, and suddenly you're logged into Spotify. But here's what's wild. Spotify never saw your Google password. Not even for a millisecond. It never touches it. So how does Google tell Spotify this is a real user, trust them, without handing over the password? That's OAuth 2. And this is part one of a three-part series on authentication. Before OAuth, if an app wanted your data somewhere else, say a calendar app wanting your Google Calendar, it just asked for your Google username and password directly. You type your real credentials into the third-party app. It would store them, log into Google as you, and pull your calendar. This is called the password anti-pattern. And it's catastrophic. The app now has your password. If they get hacked, your Google account is gone. If they're malicious, they have full access, not just your calendar. And you can't revoke it without changing your password, which kicks out everything else. OAuth was invented to kill this. The core idea, instead of your password, you give the app a limited scope token. It says, this app can read my calendar and nothing else. No password, revocable anytime. OAuth has 4 actors. Understanding them is the key to the whole flow. Resource owner, that's you, the human who owns the data and decides who gets access. Client, the application that wants access, like the calendar app. Note, client means the third-party app, not your browser. Authorization server, the system that verifies your identity and issues tokens. That's Google's Auth server. It shows you the "Do you want to grant access" screen. Resource server, the API that holds the actual data. Google Calendar's API and the key insight. The client never verifies your identity directly. It goes through the authorization server. That middleman is everything. Let's walk the authorization code flow, the most common and most secure OAuth flow. Step 1, you click Sign In with Google. The app redirects your browser to Google with a request, including a scope. Scope is critical. It defines exactly what the app is asking for, not your password, just email and profile. Step 2, you authenticate. Google shows its own login page on Google's domain. In Google's UI, the client app never sees this. Step 3, you grant consent. Google shows the consent screen. Spotify wants your name and email address. You click Allow. Step 4, the authorization code. Google redirects your browser back to the app's redirect URI with a short-lived code, usually expiring in 60 seconds. It's not an access token yet. It's just proof that you said yes. Step 5, the token exchange. Now the app's backend, not your browser, makes a direct server-to-server request to Google's token endpoint, sending its client secret and that code. Google verifies everything and responds with an access token, and optionally a refresh token. Step 6, access the resource. The app calls Google's API with the token in an authorization header. Google checks the token, sees the right scope, and returns your data. Here's the key security insight. The authorization code travels through your browser, which is less secure, but the actual token exchange happens server to server, invisible to the browser. So what is an access token actually? Most modern ones are JWTs, JSON Web Tokens. A JWT has 3 parts, separated by dots: a header, a payload, and a signature. The payload is base 64 encoded JSON, holding claims like sub, the user ID; scope, what was granted; EXP when it expires, and ISS who issued it. The signature is a cryptographic hash that lets the resource server verify the token wasn't tampered with, without calling back to Google every time. But note, an access token proves what you're allowed to do, not who you are. That's where OIDC comes in. OAuth was designed for authorization, delegating access. It was never designed to answer one question: who is this user? But when Spotify says, sign in with Google, it doesn't just want your calendar. It wants to know who you are to create or look up your account. OpenID Connect, OIDC, is a thin identity layer built right on top of OAuth. It adds one thing: an ID token. The ID token is a JWT full of identity claims: your user ID, email, name, picture. The access token answers what you can do. The ID token answers who you are. OIDC also adds a standard userinfo endpoint for fresh profile data, and the scope that triggers it is OpenID. Request OpenID, email, profile, and you're asking for an ID token. So when you sign in with Google, you're almost certainly using OIDC. So when do you use which? The rule of thumb is simple. Need delegated access to a resource. Post tweets for me, read my Drive files. That's OAuth 2. Need user identity. Sign in with Google, who's the logged-in user, is their email verified. That's OIDC. Most modern social login flows use both together. OAuth for access, OIDC for identity. So to recap, OAuth 2 solves the password anti-pattern. Instead of sharing credentials, you grant limited scope tokens, and the authorization code flow keeps the token exchange server-side, away from the browser. OIDC adds an identity layer on top, an ID token that tells the app who you are, not just what you can do. Together, they're the foundation of almost every modern login system on the web. In Part 2, we tackle SAML, the older sibling that still dominates enterprise SSO, solving the same problem with XML instead of JSON. If this clicked, subscribe, and I'll see you in Part 2.